Ayan. Bali, this is lecture number 6, slope stability. Dalawang parts itong i-discuss ko sa inyo. First part is, unahin natin yung infinite slope. Then, second part is finite or finite slope. Ano ba ang importance ng pag-alam ng stability ng slope? So, assessing a slope stability is a challenging yet important aspect of civil engineering. In its simple form, limit equilibrium methods are used and stability is determined by the equilibrium of shear stress and shear strength. So, ito naman guys, nagagamitan natin ito ng Mohr circle. Diba? Pagka mga ganyang gusto mong hanapin yung shear strength, diba? Shear stress. And then, if the forces that resist the movement are greater than those driving the movement, the slope is considered stable. So, dapat naman talaga mas dominant yung mga forces na lumalaban than sa mga forces na nagkukos para maging unstable or ma-disturb yung soil. So, sabi dito, no, a factor of safety is calculated by dividing the resistance by the driving forces. So, dapat yung factor of safety, it should be greater than 1 para stable. Diba? Meaning, kung greater than 1 siya, mas malaki yung numerator, which is the resistance force or resisting force, mas malaki than the driving forces. Diba? And what causes the resistance ng soil when it comes to slope stability? So, dalawa siya. It can be frictional force and then it can be cohesive force. Okay? Nakaka-resist siya ng driving forces. Okay? So, mamaya, mas matututunan nyo siya as we compute. So, slope stability analysis is implemented in numerous applications of civil engineering projects like dams, embankments, excavated slopes, and natural slopes. So, alam naman natin, pag mga dams, embankments, excavated slopes, there is sloping soil structure. So, pagka sloping yung soil, of course, there are possibilities, madami, like pwedeng magkaroon ng erosion, di ba? Erosion, pwedeng magkaroon ng madaming disturbances or possible na maging way para masira siya, factors para masira siya. So, dapat nadi-design din natin yung slope stability. So, doon papasok yung importance ng topic na to. Okay? So, ayan. Let's start with the analysis of infinite slope. So, I am going to introduce 2 categories now. One is kapag without seepage. Okay? Meaning, walang nagpo-flow na pour water. And then, the second one is, of course, with seepage. So, unahin natin, without seepage, this will be your formula. Ayan. So, without seepage, we simply consider the factor of safety equal to the cohesion all over gamma of the soil times the height, ayan, sa figure naman. Then, sine beta, cosine beta, plus tangent phi being the angle of internal friction, tangent over tangent beta. Beta being the angle of backfill from horizontal. Okay? So, ayan, no? H is the thickness of the layer of the soil. Vertical, distance, no? Ayan. So, let's consider naman pag walang or kapag may seepage. Okay? So, pag may seepage, may pour water. Tama. And, ang pagkakaiba lang nila ni without seepage is imumultiply mo lang ng gamma saturated yung first term or imumultiply mo lang yung denominator ng first term ng gamma saturated and then sa second term, imumultiply mo lang ng gamma sub over gamma sat. Gamma submerged is the gamma saturated ng soil minus gamma ng water. So, later on, we will notice or we will compute, no? Makikita nyo naman kung paano kino-compute yung gamma saturated, gamma submerged. And I believe, naturo naman na sa inyo yan. Tama? Ayun. So, sige. Let's consider another parang category. Pero itong part na to, guys, may failure plane na siya. Or may trial failure plane. So, pag may trial failure plane, guys, the manner of solving for the factor of safety is simply resisting force over driving force. Resisting force, ano nagre-resist? Para hindi gumalaw yung ating soil structure, the frictional force, and the cohesive force. Okay? Then, yung mga driving force naman, isa lang naman siya, which is yung component ng weight along this direction. So, di ba kung may angle yan, if this is angle theta, this is also angle theta. Tama? Therefore, this component here is W sine theta. At yun yung magsisilbing opponent nung dalawang resisting force. Okay? So, yun na yun. Again, factor of safety is simply the ratio of the resisting force over the driving force. Okay, so, paano kino-compute yung frictional force? I believe, alam nyo na yon kasi tinuturo to sa engineering mechanics. That frictional force is simply mu times n. Now, if mu is not given, we compute for mu by using tangent phi. Tama? Tangent phi is equal to mu. And then, to solve for the cohesive force, you simply multiply the cohesion, okay, times yung nito, guys. You will consider this length. Tawagin nating, distance D. So, i-multiply mo lang sa D times yung width. Ang width naman lagi, guys, ng, ng soil structure. Pag dams, retaining wall, we always consider 1 meter width. So, 1 na lang yan. Pero pag may sinabing certain width, you follow the given width. If not given, we always assume 1. Okay, so ayun na yun, guys. That's it. And let's proceed to the solving proper. Okay, so I'll only show 2 problems under the infinite slope. Okay, kasi 2 problems ay enough na para mag-gets nyo yung concept niya. Okay, so for the first problem, we have the given soil structure, and then meron tayong given na mga properties ng soil. We have the specific gravity of the soil. We have the void ratio. We have the cohesion. We have beta. Guys, beta po ito ha, beta. And then we have angle phi. So, complete naman yung mga given. So, pinapatanong sa atin, what is the saturated unit weight of soil? Factor of safety against sliding. If may seepage, factor of safety against sliding. If there's no seepage. Okay, so let's answer number 1. Okay guys, so we know naman, when we solve for the saturated unit weight, we simply use the general formula, degree of specific gravity, SE over 1 plus E times gamma water. Wherein, kapag saturated, S is 1. Okay, let's substitute all the given values. We have 2.68 plus 1, then E over 1 plus E. Then gamma of water, we use 9.81. Therefore, the saturated unit weight is 2.68 plus 0.65 over 9.81. So, we have 19.7984 kilonewtons per cubic meter. Okay? So, that's your answer for number 1. Next item. Okay, so compute the factor of safety against sliding along the plane AB If h is equal to 3 meters, there is a seepage. Okay, there is a seepage through the soil and the groundwater table coincides with the ground surface. So, meaning guys, ito yung water table niya. Okay? So, meaning, yun nga no, saturated yung ating soil. So, may seepage, tama? May seepage, therefore, ano po ang ating gagamitin na formula para sa factor of safety? Ano sabi doon? We use C over H gamma sat sine beta cosine beta, then gamma sub tangent phi over gamma sat tangent beta. Okay. Let's solve for gamma submerge. Guys, ano formula ng gamma submerge? That is gamma saturated minus gamma water. Okay? So, we have gamma saturated from our previous problem, 19.7984. Tama? 19.7984 minus 9.81. So, what is our gamma submerge? 19.7984 minus 9.81. So, we got 9.9884 kilonewtons per cubic meter. 9.9884. Okay? So, the factor of safety, let's put in the values. We have C is 14.4 over H, which is 3 meters. Gamma saturated, which is 19.7984. Sine beta, beta is 20. Cosine 20. Then, gamma submerged, 9.9884. Tangent phi, phi is 26 over gamma saturated, tangent beta. Okay, so kindly, kindly calculate. Ito ko na lang ilagay kasi wala na tayong space. So, it's the answer, guys. 14.4 over 3, 19.7984, sine 20, cosine 20. Okay, 9.9884, tangent phi over 19.7984, tangent 20. Okay, so we got 1.4304. Okay, so how can we describe our the stability of our slope? Is it stable? Definitely stable because this is greater than 1. Sabi natin, ang ideal na FS or factor of safety should be greater than 1. So, meaning the structure is stable. Okay? Next. So, for the factor of safety without seepage, what is the formula? That is C over H gamma sine beta cosine beta plus tangent phi over tangent beta. Ayun. So, we simply substitute. We have 14.4 over 3 gamma of the soil 19.7984 sine beta cosine beta, then tangent phi over tangent beta. Okay, so what is Fs? 14.4 over 3, 19.7984 sine 20 cosine 20. Okay, then tangent 26 over tangent 20. Okay. So, the answer is 2.0944. Okay. What can you say about the stability? It's far more stable than one with seepage. Tama ba? Tama. Okay. Ano kaya yung factor? Ano sa tingin niyo yung factor? Bakit pag may seepage, mas siya? Mas weaker than without seepage. I think you can already say, no, na kapag siya ay without pag siya ay without seepage, mas siya? Mas matibay. Tuyo kasi siya. Tama ba? Parang walang erosion na mangyayari. So, stable. Clear? Yan. So, we're done with the first problem. Let's proceed to the next one. Last one, actually. Okay. So, we have problem number 2. This one naman, guys, meron siyang trial failure plane. So, iba yung way ng pag-solve ng factor of safety niya as compared to the first problem. Okay, so a cut slope is to be made as shown. The unit weight of soil is 17 kN per cubic meter and the angle of internal friction is 20 degrees. Okay, so that is phi. Phi is 20 degrees. The soil has a cohesion of 28 kilopascals. The cut slope makes an angle of 30 degree with the horizontal, meaning, ito yun guys, that is your 30 degree, yun yung cut slope from the horizontal, and the trial failure plane is 15 degree from the horizontal. Okay, so determine the following. First, frictional force along the failure plane. Second, cohesive force along the failure plane. Third, factor of safety against sliding. Okay. So, first thing to do for number 1, find the frictional force along the failure plane. Guys, how do we compute for the frictional force? That is simply mu times n. Mu times n. And how do we solve for mu? Let's solve for mu. Mu is simply tangent phi. So, what is the value of phi? Phi is 20 degrees. Therefore, mu is 0.364. Okay, 0.364. Now, let's solve for n. Where is n in the figure? N is the normal force with respect to the failure plane. So, if this is your failure plane, the perpendicular or normal force there is this one. Perpendicular to the surface. Now, since we have here the weight, may component yan. It has a component vertical or perpendicular to the failure plane. Meron din siyang component na parallel dun sa failure plane. So, kung gagawa ako dito guys ng cross, will you agree na if this is theta, this is also theta? Agree? Yes, that is through geometry, no? Napuprove natin na angle theta din yan. So, if theta is 15 degrees, ayun, yan. Therefore, we can solve for n by taking summation for n. We take summation of forces na ganyan. Ito yan. Summation mo lang tong component na to, saka ito. Tama? Para ka nagsa-summation of vertical force, but hindi siya vertical eh. Kumbaga, perpendicular siya with respect to the plane. Okay? So, equate mo lang siya sa 0. So, we have there, how do we call this component, guys, of the weight? This is adjacent siya dun sa, sa angle. So, that is W cosine theta. And this one here, of course, that is W sine theta. Okay? So, by taking summation of force along or perpendicular to the failure plane, we can say that W cosine theta is equal to the normal force. Okay? So, guys, what is the normal force? Normal force is equal to W. What is the value of W pala? Guys, let's solve for W. Tama ba? W is, we know that gamma is equal to weight over volume. Tama? Therefore, weight is gamma times volume. So, to solve for the weight of the soil, gamma ng soil times volume ng soil. Anong volume yung i-consider mo? Ito. Kasi ito naman yung cut slope. Right? Okay, so that will be the volume na i-consider natin. So, to solve for the weight, ano ba yung gamma natin? Let's go back. Gamma of the soil is 17 kilonewton per cubic meter. Okay. So, we use 17. And guys, ano volume nung shaded na red? Area niyan is 1/2 base. Let's consider this one as A. And then, let's consider H is the height. So, 1/2 AH. Area ng triangle. Are you following me, guys? Can you follow? Can you follow? Okay. So, area ng triangle is 1/2 base times altitude. So, we have 1/2 A times H. And then, the width is, of course, 1. Now, 1. So, let's solve for 817. Okay. Kaya lang, guys, wala pa tayong value ng, natin. Wala pa tayong value ng A. Tama? Wala pa tayong value ng A. Can we compute for A? Of course, we can. Pwede natin siyang isolve kasi we can solve for, using this triangle, we can solve for this length. Let's call it x sub 1. And then using this triangle, we can solve for this length. Let's call this as x sub, wait. So, this is x sub 1. And then this length, let's call this one as x sub 2. Okay, so for x sub 1, what is x sub 1? Okay, so we using tangent. We can use tangent, no? So for x sub 1, we have tangent theta is equal to h, which is 3. That is your h, no? Yung opposite side, over adjacent, which is x sub 1. Okay? So, may value tayo ng theta, which is 15. We have tangent 15 is equal to 3 over x sub 1. So, what is x sub 1? What is x sub 1, guys? X sub 1 is 3 over tangent 15. Okay, so this is 11.196. 1962 meters. And then, we solve for x sub 2. Okay, so for x sub 2, guys, we use this triangle. So, tangent, what's the value of this one, guys? That is 30. If you can remember, 30 yan. So, diretso ko na, no? Tangent 30 is equal to 3, which is h over x sub 2. So, what is x sub 2, guys? X sub 2, x sub 2 Nangyari, ba't ang laki? Ayan, x sub 2 is equal to 3 over tangent 30. 5.1962. Ayan, 5.1962. Therefore, guys, what's the value of A? What's the value of A? A is x sub 1 minus x sub 2. Okay, diretso na guys ha. So, x sub 1, 11.1962. Then, x sub 2, 5.1962. Ayan, so, this is 6 meter. Okay? Sorry. Ay, nag-next. Okay. Okay, so the value of A is 6 meters. So we can now proceed, guys. Continue ko na ito. So we have here 17, which is gamma. 1/2 6 times 3. Tama? 1/2 6 times 3. Then width is 1 meter. Okay, so what is the value of the weight? Okay, so 17.56 times 3. So we have 153 kilonewtons. And we solve for N. N is equal to W cosine theta. So we have W, 153. Then we have the angle theta, which is 15 degrees. So what is the normal force? W cosine 15. Okay, so we have here 147.7867. Notice, guys, that I always consider up to 4 decimal places. I expect na kayo din, pagka nagpapa-quiz ako or nagpapa-exam, make it, no, yung, wag nyo na isulat yung buong decimal, sa buong decimal part. 4 decimal places will do. Okay? So, 147.7867 kilonewton. And then, of course, we have the frictional force now, which is mu. What is mu? 0.364. Naalala nyo yun? Ito siya. Na-compute natin siya from here. 0.364. Okay. Times N. So, the frictional force finally is 364 times 147.7864. 0.364, 147.7864. So, we have 53.7942 kilonewton. Okay. Next pa item. Item number 2. Okay, compute the cohesive force along the failure plane. Of course, this one is much easier because we know that the cohesive force is simply cohesion. Then you simply determine this length. We denote this length as distance D times the width, which is 1. Okay, so let's solve for D. What's the value of D, guys? Can we solve for D? Of course, we can. So, considering na lang itong triangle na to, guys. Tama? We can solve for D using sine. So, this is H also. So, to solve for D, sine theta is equal to opposite, which is H, over the hypotenuse, which is D. So, sine theta is 15, H is 3, then D. So, what is B? D is 3 over sine 15. Okay. So we have 11.5911. 11.5911 meter. And we can now solve for the cohesive force. So that is cohesion, which is 28, times D, which is 11.5911 times 1. So, 28, 11.5911, 11.5911. Okay, so we have 324.5508 kilonewtons. 324.5508. Okay? And finally, to solve for the last item, compute for the factor of safety against sliding. So we have the formula, cohesive force plus frictional force over W sine theta. So, substitute na lang natin, guys. What's the value of FC? That is FC, guys. Yan, kakasolve lang natin kanina. FC is 324.5508. Then, what is the frictional force? Okay, frictional force, we have, 53.7942. 53.7942 over W. What is W? W is 153. Okay, 153 sine theta. So, what is the factor of safety? 324.5508 plus 53.7942 all over 153 sine 15. So, we got 9.5543. So, that's it, guys. That ends our part 1. So, tune in kayo, guys, or keep posted sa ating Facebook group. I'll upload or I'll give an announcement kapag na-upload ko na yung sa finite slope. Okay? So, ayun, guys. Thank you.